Here is what you need to know before using LiteSync. There are two types of nodes, primary and secondary. The primary nodes store the synchronization logs together with other tables, so their database is bigger. The secondary nodes are light, and thus better suited for mobile and IoT devices. You can create a single application and use it on all nodes. The only difference between them would be the connection string, used to differentiate the primary and secondary nodes. Or you can use a very simple app without database access in the primary node, just to keep LiteSync working in the background, normally on the cloud or on a dedicated local device. Or create a different app for the primary node, maybe with some back-end logic like data management, stats, and reports. There are three possible network topologies. In the star topology, we use a single primary node and many secondary nodes connecting to it. It is a simple arrangement, but it requires the primary node to be always active for the synchronization to take place. In the peer-to-peer topology, we have only primary nodes, so all of them store synchronization logs. They are like clones of each other. If one fails, the others continue working. The synchronization happens while the majority of the nodes is online. And in the mixed topology, we have peer-to-peer nodes and secondary nodes connecting to them. The primary nodes do not need to be using the same application. If a primary node fails, the secondary nodes connected to it will connect to another primary node. This is a robust setup with advantages from the other two topologies. But how we define the type of each node and the connections between them? Very simple. Instead of opening the database with just a path, your application will also inform the type of node and the TCP connection. Normally, we bind to a TCP address on the primary node and connect to it on the secondary nodes. Now, some rules. The database must be local. Do not open the DB on a network shared folder. Each node should access its own local database. Start with an empty database, meaning no files. This is a requirement for secondary nodes. Do not distribute your app with a pre-populated database. It can create tables with SQL commands. If you want to use an existing pre-populated database, place it on one of the primary nodes, in just one of them. The database will then be replicated to the other nodes. Your app can use a single connection to the local database if single-threaded. If it has many threads, each one can have its own connection to the local database. If you have another app on the same device, they cannot use the database at the same time. Each application will need to use a separate local database. Alternatively, one app can act as a small server to handle requests from other local apps. The connection must be kept open while the application is running. This is because the synchronization depends on that open connection to happen. So if you close it, there is no sync. Wait until the DB is ready before using the connection. The method for doing this depends on the programming language you will use. This is required because the library may need to download the database from other nodes. Do not use auto-increment when creating tables. But don't worry, most apps don't need it. Here is how it works. When you have a table, then delete the last row and insert another. A table with auto-increment will not reuse the deleted row ID. Currently, this is not supported by LiteSync. If you want to avoid the reuse of row IDs, you can use logical delete instead. Just mark the row as deleted. Then when a new row is inserted, it will always have a fresh row ID. Now let's talk about conflicts. Nodes can insert rows on tables simultaneously, even when offline. If they insert rows with the same row ID, then we have a conflict, and only one of the insertions will end up in the synchronized database. To avoid conflicts on row IDs, LiteSync uses a different numbering method, composed of the node ID and a sequential part. This is better viewed in hex format. All rows created by a specific node will contain its node ID on it, thus avoiding collisions with rows from other nodes. This feature applies only to tables with integer primary keys. For other types of primary keys, like text or composite, collisions can happen. So give preference to integer primary keys. Remember that for the special row ID to be used, you should not specify an explicit row ID when inserting a new row. There is no other special handling of conflicts. When there are two conflicting commands to be synchronized, it does not matter which was created first. They will be processed in the order they reach the primary node. For constraint violations caused by the same value on the two commands, the first command to be synchronized will succeed and the next with the same value will fail. The failed transaction will also be reverted on the originating node. Now let's check concurrent updates with different values. On this case, the last command to be synchronized will overwrite the value from the previous command. The commands execute normally, there is no reversion, but one of the values is no longer on the database. It is possible to view all the SQL commands generated on each local device. They are saved locally on a log file together with other DB files. The transactions which failed on the synchronization are also saved to a local log file together with the error message so that you do not lose any data. To know if a transaction was successfully synchronized or reverted, your application can subscribe to an event notification. The method for doing this depends on the programming language your app uses. Your application can also receive a notification when the local database is updated with new data from other nodes. Check the documentation for the programming language to learn how. You can use encryption on the database and on the communication between the nodes. This is recommended to add security to your application to block external actors from viewing and overwriting your data. To learn more, check our video about encryption. That is what you need to know to use LiteSync on your application. Use our community forum if you have any question. And happy hacking!